Problem number 4. Two beads, each of mass small m, are free to slide on a rigid vertical hoop of mass big M. The beads are threaded on the hoop so that they cannot fall off of the hoop. They are released with negligible velocity at the top of the hoop and slide down to the bottom in opposite directions. The hoop remains vertical at all time. What is the maximum value of the ratio small m over big M such that the hoop always remains in contact with the ground? Neglect friction. Solution. So first we can count what is the acceleration of each bead for any position. Let's do this. Suppose that both beads now reach the angle theta on this picture. I show only one bead, but other is in the same position in opposite direction. Now we can count both accelerations, tangential and normal. Tangential acceleration could be found from formula at equal negative g sine theta. And normal acceleration could be found from knowledge of velocity in this point. Velocity we can find from energy conservation. This is the equation. And now we can find what is v squared, this one. And we know that normal acceleration equal this expression. So in any point we can count what is tangential and normal acceleration. But we are interested in the total vertical acceleration in y direction. For that we have to find what is a projection of a tangential acceleration on the axis y and projection of normal acceleration of axis y. So we need to multiply tangential by sine theta and multiply normal acceleration by cosine theta. And now we have to add them. So for this, after this operation, we can find that total AY equal this expression. Now let's see. Our bead moving vertically with this acceleration, but it creates by force of gravity and by reaction from hoop. We can write this equation. So here we have MAY equal negative mg plus force from hoop, vertical force from hoop. So from here we can immediately find what is the vertical force from hoop. That will be this one. And now we can count what is maximum for this force. Maximum we can reach for angle with the cosine theta equal 1 over 3. So it means that force Fy equal negative 1/3 mg. If this force acting on a bead in negative direction, it means down. It means that this bead acting on a hoop with the same force. But because we have two beads, we acting on a hoop with the force 2/3 mg. It means that if we apply force greater than big mg, our hoop will jump. So solution will be when 2/3 mg less than big mg. And finally we have this relation. For this relation small m over big M less than 3 over 2, this hoop will never jump. There is another way to solve this problem. We don't need to split our acceleration by tangential and normal, because we already counted what is the velocity in any position, and we can just take a derivative from velocity and find what is acceleration in any position. So we already counted what is the velocity for an angle theta. This is the expression, and we can find what is the projection of this velocity on a y direction. That will be this one, and it's negative because it's going down. Now let's take first derivative by time from this velocity. We have this expression. We can count this derivative, and we see that delta theta over delta t, that's omega, that's the angular velocity of this motion, and we know that angular velocity, that's just equal v over r, and we can use this formula for v and to substantiate it here. So finally we have acceleration equal this equation, and after simplification we can find that total acceleration will be like this. And if we check the acceleration in the first solution, that will be the same. So we have the same result.